Hi, in this video we will use fundamental theorem of calculus to evaluate definite integrals which are going to give the area of a region under the graph of a positive function. Well, just recall that when we have a positive and continuous function like f of x, the region between the graph of this function and the x-axis on the interval AB is given by, so the area of such a region is given by integral of a to b of f of x dx. We have used this before, and actually before we had this Riemann sum or left approximation, right approximation definition for area. Now that we know that this is equal to this integral, and we have fundamental theorem of calculus part 2, we can actually evaluate some of these areas without going to the computations of sums and right approximation sums and limit and so on. So that's just basically new way of computing the areas, and this is just two examples. This video will include two examples here. Okay, first thing here, that find the area under the graph of sine x. First thing to note is that sine x on the interval 0 to pi, it has a graph like this. So it goes down there and then comes up. Yeah. So in this interval, this is positive function. So the area is equal to integral of the function on that interval, 0 to pi. Well, up to this point we already knew, but the new thing that we have is the tool to compute this integral. That's fundamental theorem of calculus. We know that negative cosine x is an antiderivative for sine x, and by fundamental theorem of calculus part 2, we know that the value of the definite integral is evaluation of antiderivative at the top, at the upper limit minus at a lower limit. So minus cosine pi minus negative cosine 0. Cosine of pi is -1. There's a negative sign also there. This is negative plus. Cosine 0 is 1. So this adds to 2. So the area of the region under the graph of sine x on the interval 0 to pi is equal to 2. This is another example. Well, remember that the exponential functions are always positive functions, and in this case specifically we have 2 to the power x on the interval 1 to 2. Actually, we did find this limit before this area, before using the limit and Riemann sum and right approximation. Well, here now we have another way of computing that. We have to integrate 2 to the power x dx from 1 to 2. We need to, we want to evaluate this definite integral. We know that an antiderivative for 2 to the power x is 2 to the power x over ln x, ln 2, not x. And by fundamental theorem of calculus part 2, now we know that we can evaluate this integral since we know the antiderivative of that function. This will go 1 to 2. This means 2 to the power 2 ln 2 minus 2 to the power 1 ln 2, which altogether this will be 3 over ln 2, which is a positive number in this case, and that's the value of this the area of this region. Yes.